the next thing I look for is the geometric series test, because this one's the best. First of all, let's talk about what a geometric series is. A geometric series is a series where each successive term has a common ratio. So in other words, we can multiply the first term by some value to get the second, multiply the second term by the same value to get the third, and so on. Now sometimes so here we've got find the common ratio for each geometric series, then write the series in summation notation. So let's just take a look at this for a moment. For some of you, you can probably look at that and say, oh yeah, I see the pattern. I can see what's being multiplied each time. But it's not always obvious. So if I'm telling you, first of all, that this is for certain a geometric series, then that means there must be some common ratio. There's something we're multiplying each term by in order to figure out the common ratio, or to find each term. Sorry, I lost track of my thought for a moment. So let's see if we can find the common ratio. There is a way to do this without guessing and checking or just hoping you can notice the pattern. If I take the next term, let's say 4, and divide it by the previous term, that will give me the common ratio, 2/3, which you may have already seen already. So if I take the next term, 8/3, and divide it by the previous term, 4, that's 8/3 times 1/4, again, 2/3. So we have the common ratio. The way a geometric series works is we start by saying, here's the original term. So the a sub 0 term is 6. The common ratio is 2/3 in this case. So to write this, the general term for this sequence of numbers, of this series of numbers, we would say, all right, let's start with 6. We're going to multiply it by 2/3 to the power of n, where n is 0 first, because 2/3 to the 0 power is 1. 1 times 6 is 6. 2/3 to the first, that means 6 times 2/3 would be 4, and so on. So every time we write a geometric series, here's the original term, a sub 0 term, and there's the common ratio. So if I were to write this in summation notation, because notice the plus dot dot dot, I would write it like this. N starts with 0. Since the dot dot dot, we're going to infinity, and the expression is 6 times 2/3 to the power of n. So that's what I'm looking for on these, and I'm going to give you a couple more to try. See if you can write these all in summation notation or sigma notation. So here are 3 more. Give it a whirl. See what you can do. Okay, welcome back. I notice on B, my original term, my 0th term, is 1. And I can see that the common ratio I'm multiplying by 2 every time. So in summation notation, this is from n equals 0 to infinity. I'm starting with my original term of 1 and then 2 to the n. Do you need to have the 1 there? Of course not. You can just write this as 2 to the n power, and that would be absolutely okay. All right, let's look at part C. Part C, a sub 0 is 7. The common ratio is 1. So what we end up having is the sum from n equals 0 to infinity, the original term, times 1 to the n. Do we need the 1 to the n? Absolutely not. You know what? I'm going to rewrite these so you can see. Because 1 to the n, no matter what n is, will always just be 1. So I can rewrite this first one to be more clear as just 2 to the n power. That's a geometric series. First term is 1, common ratio 2. This next one, I do not need to write that 1 to the n power, but I just wanted to continue on with the pattern. So what you could do is you could write this as n equals 0 to infinity 7. I just wanted to show you that geometric series setup. Okay, now this next one, my first term is 10. Looks like I'm multiplying by negative 1/2 each time. Okay, in summation notation, n equals 0 to infinity 10 times negative 1/2 to the n power. All kinds of ways to rewrite that one, not important right now. It's good enough for right now. All right, so that's an introduction to a geometric series. Now let's look at these and determine, let's just think about this for a moment. I'm kind of jumping the gun, but I don't mind. Which of these do you think converges? So which of these can you say for sure will diverge? And then which of these do you think would converge? So the first one, actually let's look at the obvious ones. Let's look at B. B, we're just adding on larger and larger values as we go. So we can say for certain that B will diverge. And that's the nth term test. Because if we wrote this as a sequence of numbers, those numbers are definitely not approaching 0. So by the nth term test, this series will diverge. This is an important thing because this is where we start using those things. Diverges by the nth term test. Because the limit as n approaches infinity of 2 to the n does not equal 0. Similarly, on part C, we're just adding larger, we're just adding 7 plus 7 plus 7. There's no way this is getting smaller. So the limit as n approaches infinity of 7 does not equal 0, diverges by the nth term test. Now I will tell you that the other two, A and D, in a geometric series, and we don't have the time for me to prove for certain, but in a geometric series, these terms are approaching 0 fast enough because 2/3 to the n power gets substantially small quickly. 2/3 to the 5th, 2/3 to the 10th, that is getting closer and closer to 0 rapidly. So these geometric series are approaching 0 fast enough. So that means A and D definitely converge. Even though D is oscillating between positive and negative, those numbers we're adding on, some are taking away from the others, so we're definitely getting closer to 0 here, especially because -1/2 is to the n power. Okay, so let's look at the geometric series test. This one can prove convergence or divergence, as long as the absolute value of r is less than 1. In other words, as long as those numbers are getting smaller. So if we're multiplying by a fraction that's less than 1, then the geometric series converges, and we can actually calculate the sum. So far, all we've been saying is converges or diverges. But with a geometric series, we can actually calculate what the sum is going to be. It's by taking the first term, that a sub 0 term, divided by 1 minus r. There's a whole proof for that, and feel free to look it up. That's outside of the scope of this class. Now, if that ratio is greater than 1 or equal to 1, like it was when we were doing 7 plus 7 plus 7, then we can say for certain that the series will diverge. So here's the second geometric series test. I can't remember what color I highlighted the other one in, but this is a big one. Here's your second, that's hard to see. Here's your second convergence test or divergence test. The first one was the nth term, and now the geometric series. So these are literally in the order that I would check as well. First thing I would check, make sure the terms are getting smaller. If not, we can say diverges. Second thing, is this in the form of a geometric series? If so, check R. If R is less than 1, we can say for sure converges, and we can find the sum. Greater than 1 or equal to 1, for sure diverges. All right, let's do some examples. We're going to do this first one, and then I'll give you a chance to do the rest to practice. So we're going to look at this first one. It's probably going to be too easy, but it's still good. We'll do the first two together. How's that? So in this case, I can see that this is definitely in the form of a geometric series because I am from 0 to infinity. Here is a sub 0. There's the first term, and here's r. So the first term is 3. The ratio is 2. 2 is greater than 1. This series diverges. It's so nice to not have to write out all of those partial sums. We can just say that for certain. These terms are just getting bigger and bigger. Okay, let's look at B. We'll do B together. B looks tricky, a little bit scary. First of all, we know this is from 0 to infinity. So this is going to work for a geometric series if it's a geometric series, but we're going to have to do a little bit of rewriting of this expression. So first of all, I can take that 4 out because it's not an exponent. I can write this as 4 times 1 over 3 to the n. Another way I can rewrite this, because that's a 1 in the numerator, I can write this as 1 to the n, because 1 to any power is still 1. And then finally, the last transformation I can make to this is I can, since that's 1 to the n and 3 to the n, I can just write this as 1/3 to the n. All right, now I can see a lot more information on this thing. I can say that a sub 0 equals 4. I can see that r is 1/3. And we can say that because r is less than 1, this series converges. I didn't leave enough room to find the sum, but I will anyway, by the geometric series test. Ugh. Sorry, I ran out of space there. I apologize. But we do need to find the sum of this. The next one's not, well, all right, so we do need to find the sum of this. I'm going to move these down because I want some space. I don't want to keep cramming this in. All right, so finding the sum then is the first term, which is 4, over 1 minus r. Okay, let's simplify this because you will see this on a multiple choice test, so we're going to practice simplifying. 1 minus 1/3 is 2/3. 4 divided by 2/3 is 4 times 3/2. So the sum of all of these is 6. If we added all of these terms, the sum approaches 6. But we can say it equals because eventually we're going to not add on anything big enough to change that sum overall. All right, so because r was greater than or less than 1, we knew that the series converged by the geometric series test. And because this geometric series converges, we could then find the sum using that formula. All right, now I'm going to give you a chance to try a couple of these. Be very careful. Notice some of the details that I put in there. There are reasons I'm giving you these 3. So go give it a shot. Okay, there are a couple ways you can go about doing this. I think for me, I don't know, it's up to you, but what I can see is that this kind of looks geometric because it's 3 times 2/3 to the n. However, we're not starting at 0. So what I could do is make a horizontal shift. So if I shift everything like 4 to the left, in other words, I want this to start at 0, I can write this as n equals 0 to infinity. And what that would mean is I would have n plus 4 then. That way, my first term will be the same. If I plug 4 in for n in the original, that's 3 times 2/3 to the 4th. If I plug 0 in my new one, 0 plus 4, it's still 3 times 2/3 to the 4th. So I just made a horizontal shift. But this still doesn't look geometric to me. Okay, we learned a little bit about some properties of exponents where I can deal with this. So I am going to deal with that. I'm going to write this as 3 times 2/3 to the n times 2/3 to the 4th. Okay, I'm going to move these down because I still didn't leave myself enough room. Now I can see what a is going to be. It's not pretty, and I'm going to probably do a little bit more with this, but 3 times 2/3 to the 4th is my a term. It's the very first term because now here's r, sorry, there's the ratio. This is a. So let's talk about convergence first. The absolute value of r is less than 1, therefore converges by the geometric series test. The sum of this series then is the first term, which is this gross thing, 3 times 2 to the 4th over 3 to the 4th, over 1 minus r, which is 2/3. You could leave it like this, but if this were multiple choice, we would need to be able to simplify a little bit. So let's try and simplify a little bit. This 3 will take out one of those 3's. So now I've got 2 to the 4th over 3 to the 3rd. 1 minus 2/3 is 1/3. So then I can write this as 2 to the 4th over 3 to the 3rd times 3 over 1. This 3 will take out one of those. So now I've got 2 to the 4th over 3 squared, which is 2 times 4, 8. Oops, 16/9. Did I do that right? 2 times 4, 8, 16, yeah. 16/9. There's the sum. All right, last one. Now, oh no, there's 2 more, sorry. Now that we did part C, which was much harder, part D won't be quite so bad, because I'm going to have to do some rewriting, first of all. I see this is 0 to infinity, so we're good. But I'm going to do some rewriting on that 3 to the power of n plus 1. I'm going to write this as 3 to the n times 3 to the first over 5 to the n. All right, I can rewrite again. I did not leave myself enough room for all of these. I can write this as 3 to the first times 3 to the n over 5 to the n. Then I can rewrite one more time to say 3 times 3/5 to the n. So I know that the absolute value of r is less than 1, converges by the geometric series test. Well, let's find the sum is the first term over 1 minus r. So we've got 3 over 2. I was pushing the home button. All right, last one. Let's find the sum for this if we possibly can. So first of all, does this converge? If I let a equal, a sub 0 is my first term, and it looks like r is multiplying by -1. Actually, by the nth term test, I could have said this, but still, because the absolute value of r is equal to 1, we know that this sum diverges. All right, that's it.